Problem 69, rationalize the denominator. So this is going to be a two-step solution. So I'm going to do the first step, and then the second step is going to be like something much easier. So first we want to recall the following formula. This is one of the very common formulas. So if you have like sum of cubes minus 3x yz, you can factorize this as x squared plus y squared plus z squared minus xy minus xc minus yz. So that's the expression. So imagine that this is x, this is y, and this is z. So what happens if I multiply? So this one, I have x plus y plus c with this one, both numerator and denominator. So my expression, it becomes 1. So I will try to write it accurately, the entire expression. And in the numerator, we have the squares. A square, b square cubic root, and c square cubic root minus ab cubic root, bc cubic root, and ac cubic root, right? And in the denominator, again, we have the same expression here. So, okay, assume that we have same expression down here. But what happens if I multiply this one and this one? So that gives me this formula, right? Cubes of first three numbers. So we have a plus b plus c. Cubes of these three. So if you do the cubes, that's a plus b plus 3 minus 3 product of these three numbers, that's cubic root abc, and this fraction here again. So when I multiply numerator and denominator with this number, now I have something that's an expression in the denominator that has single cubic root and something on the numerator. So now I want to get rid of this. So this is relatively easy. So you can do a cube minus b cube formula. So we did similar problem before. So if you do that, it will be a very huge expression. But the idea is, so if you multiply with this expression, you reduce the number of cubic roots from 3 to 1, and then you can use a cube minus b cube formula to get rid of this one as well. So in the end, you will end up with an expression that has no cubic roots in the denominator or any other roots.